Hello dear friends, how are you? I hope you all are good. Now in today's, so see here, as you know from 29 October, our preparation is started, okay, and on 30 October, your first paper, round first paper, so that we are going to head within two topics, solid state and haloalkane and haloring. Okay, your CBSE board preparation here it will start with your CET and NEET, JEE also preparation also started. Okay, so I hope you are doing well in that and what you will get definitely success. Okay, so all the very best for your preparation, whatever you are doing, CBSE, NEET, JEE, okay, NATA, BARCH, okay. So see here, we will discuss here. So whatever we took here first two topics for our round one chemistry. So solid state, haloalkanes and haloring. Okay. So here in round one, so whatever our which most important points you have to focus. Okay. So that we are going to discuss here. Okay. So see, we will take first whatever our solid state. Okay. So pay attention on that. Whatever I am saying, important things regarding these topics. Okay. So see here. First, we will discuss regarding your solid state. Okay. So, but as you know, in this solid state, so see, first, whatever important, that is general characteristics of solid state. Okay. So, see here, whatever general characteristics of solid state. So, in that, as you know, there are some basic properties of solid state you have to consider here. Okay, so next whatever amorphous and crystalline solids. Okay, so here amorphous and crystalline solids, amorphous and crystalline solid. So these are also very much important part. So whenever we are seeing this video, so at that time take your reference book as well as your NCERT in your hand. Okay, so whatever I am dealing here, which points that you have to focus on that points and do preparation accordingly. Okay, so amorphous and crystalline. So basic whatever terminologies are difference between amorphous and crystalline that you have to focus. Okay, so in that again crystalline solid, as you know better these things, isotropic, yes, isotropy and what? Anisotropy. Okay, so these also very much important. You have to focus on this definition. Okay, whatever properties of that isotropic and anisotropy. Okay, so next distinguish between crystalline and amorphous solid. Next what beta? Yes, distinguish between what? Crystalline and amorphous. Yes, amorphous solid. Distinguish between crystalline and amorphous solid. That also very much important here. You have to go through that, distinguish whether it is short range order, long range order. Okay, sharp melting point, then what does not show sharp melting point, definite melting point, many more in that. Okay, next whatever a classification of crystalline solids. Okay, so see here in classification, yes, classification of what? Crystalline solid. Okay, so in classification of crystalline solid, you have to first dealing with whatever your molecular solids, then that molecular solid again divided into non-polar molecules and polar molecular solids. Okay, so whatever chart they gave there, okay, so whatever the chart means, in that chart they gave ionic solids also, then metallic solids, covalent, okay, or network solids. So you also remove your you also write in one blank page whatever that chart. Okay, you revise that chart, means ionic compounds, what it is there, which type of bonding is there, so some coulombic force of attractions also present. Okay, with their examples also you have to keep in mind. Okay, so these are what important terminologies here. Next we will discuss here whatever crystal lattice and unit cell. Okay, crystal, yes, crystal lattice and what, unit cells. Okay, so in unit cells also, whatever basic terminology you have to keep in mind. If you have any doubts, you can share immediately. Okay, so here we are taking what, overview, and you have to go depth into that, and you have to what, study accordingly. Okay, so next whatever after crystal light, lattice and unit cell, possible unit cells in two dimensional. Okay, then whatever after this, what, primitive and centered unit cells. Okay, that also very much important. Okay, so see here, we are dealing with what, primitive unit cells, primitive unit cells. Then what here, centered unit cell, centered unit cells, primitive unit cell, centered unit cell. So as you know beta, primitive unit cells what, when particles present only on the corner position of unit cell. Okay, that is what beta, primitive unit cell. And centered unit cell means what, when unit cell contains one or more constant particles centered. Okay, and there are again whatever centered unit cell having three types. So which, see here, BCC, FCC. Okay, BCC, FCC and what, end centered unit cells. Okay, BCC, FCC. So after that, whatever 7 Bravis lattices, that also you have to keep in mind. Okay, so as you know that you can make like this chart beta, say C tor H. Okay, or you have to make like that chart. Say here CTOR HMT. What beta? Yes, CTOR HMT. Okay, C means what beta? Yes, cubic. Okay, then what? Tetragonal. What beta? Tetragonal. Then what? Orthorhombic, or we can say what? Orthorhombic. Then what here? Rhombohedral. Okay, rhombohedral. Then here what? Yes, hexagonal. What beta? Hexagonal. Then here what? Yes. Here what? Monoclinic. Monoclinic and what? Triclinic. Okay, triclinic. So like that you can arrange. Okay, where there are bond angles. Okay, then alpha is equal to beta is equal to 90. Alpha beta is not equal to 90. Then alpha is not equal to 90. Beta is not equal to 90. Okay, and gamma also. So like that you have to make chart accordingly. So it will come what? Means it is very easy method to memorize this all 7. Okay, whatever cubic, like we what, CTOR HMT. Okay, so as you know beta, after this all whatever our primitive unit cells and centered unit cells, we are dealing with what? Yes, number of atoms in unit cell. What beta? Yes, number of atoms in a unit cell. So here number of atoms in unit cell. So as you know, in simple cubic how much? 1. In BCC how much beta here? Yes, 2. Then FCC, HCP, CCP how much? 4. So this thing, whatever this thing, you must know here. Okay, so without that you can't go further. Okay, in solid state. So this number of unit cells, basic criteria. Okay, so after this here, closed pack structures also there in that 2D dimension, closed packing in 1D, 2D and 3 dimensional. Okay, so thereafter what, how we can locate octahedral void, tetrahedral voids with their diagram. It is also important. Whatever theoretical background you have to read thoroughly, and if any doubt will come, you can ask at the time of preparation. Okay. Now one more here important part, whenever we are going to solve few numericals, okay, simple numericals. So see here, the number of close packed sphere, the number of, yes, close packed sphere, the number of close packed sphere be n, what beta, capital N. Then then the number of octahedral voids, the number of, yes, octahedral voids, octahedral void generated is equal to what, capital N, and the number of tetrahedral void, and the number of what beta, yes, tetrahedral voids, what, generated is equal to what beta, 2n. Okay, so this thing very much important thing here you must know. Number of octahedral void means only capital N, and number of sphere, closed packed sphere, and number of tetrahedral void is what, 2n, means you have to what, multiply by 2 here. So accordingly here simple numericals also present. Okay, so among these we can solve here one. So pay attention. It is already present in your NCRD. What? In NCRD in text question also. So see, a compound on page number 16. A compound is formed by two elements X and Y. Atoms of element Y as an makes CP, and those of element X occupy all the octahedral voids. So octahedral voids means what? Simply N. So what it will be your formula? Simply what? X, Y. So see there give. Okay. And one more here important beta. That example 1.2. Atoms of element B form CP lattice, and those of atom A occupy two-third of what? Tetrahedral void. So two-third of tetrahedral void means what? Multiply by 2. So what is this? Formula of compound formed by the elements A and B. Okay, so see here, A and B. Okay, B, atom of A occupy two-third of tetrahedral voids. Okay, so two-third. Okay, so multiply by what? 2 here, because what? Tetrahedral void how much? Yes beta, how much? 2n. So what will come here? Yes, 2 into 4. So A4 B3 your count. A4 B3 is what? Yes, what is the ratio of this? A4 and B3. So they gave here answer also. Understood? So like that, on the base of this, whatever number of octahedral voids n and number of tetrahedral void 2n, like this simple numericals of 2 marks. Okay, so pay attention on this also, very much important here, this all. Okay, so see here, whatever our next. So in that, formula of compound and number of voids filled. Okay, so formula of compound is number of void filled. Okay, so you have to take these solved examples. Now one more important here, what? Yes, packing. Okay, so what beta here? Whatever packing, yes, packing efficiency. Yes beta, packing efficiency. So see here in packing efficiency, so you must know here regarding for your HCP, CCP and FCC, packing efficiency how much? 74%. So here you have to concentrate on whatever I am saying here. HCP, CCP, FCC, how much? 74% packing efficiency. Okay, so as many exams they will ask directly for 3 marks. So whatever they gave in your NCERT textbook. Okay, so calculate packing efficiency for FCC, HCP, CCP. So you must know whatever all that, how to calculate this. Okay, with radius and edge length. So whatever all already sir told about this packing efficiency. So for CBSE board exam, they can ask directly for 3 marks that calculation. Okay, calculate packing efficiency in HCP. Okay, then FCC. Then as you know better here, packing efficiency. Okay, so see, packing efficiency in what? BCC. How much beta? Yes, 68%. How much? 68%. So for such type also you will they will ask directly. Then what? Packing efficiency in what? SC. Okay. So how much here beta? Yes, 52.4%. Okay. So this thing is what? Very much important here. Now, so this whatever packing efficiency in HCP, FCC, CCP. So here in all these, whatever all these packing efficiency, beta, okay. So you have to concentrate on. You have to concentrate on radius and edge length formula. Radius is what your R and edge length is what A. So a relation between radius and edge length in FCC what? The relation between radius and edge length about if BCC and SC is what? So be careful whenever you are dealing with this all whatever if they will ask for 3 marks, then on the basis of that they will ask what 2 marks question, numerical question also they will ask. So you have to you have to you have to make your notes, short notes in terms of your FCC. So at that time you have to calculate R is equal to what, A is equal to what. Okay, then you have to calculate for BCC also. Okay, R is equal to what is the formula, A is equal to means edge length is what. Then regarding R for SC also, R is equal to how much, A is equal to means radius and edge length. Means here 2 to 3 types of question here. Means they will ask directly to what, how much packing efficiency of BCC, SC. Okay, and they will ask what is the relationship between BCC, what is the relationship between radius and edge length in BCC. Then you have to write simply what formula for this radius and edge length, and they will ask what numerical also. Okay, understood? If radius you know, then edge length you have to calculate, edge length you know, radius you have to calculate. So see, they gave in your NCERT exercise also such type of questions. Okay, and already I gave one worksheet also on solid state. Okay, so these are what important things here. Now after this, see here beta, after this in your solid state, whatever calculation involving unit cell dimensions. Okay, so see here, calculations, yes beta, calculations, very much important is also calculations involving, yes, unit cell dimensions. Okay, unit cells dimension. So as you know this formula, our D is equal to what, Z into M divided by what, A cube into Na. Z is what, beta, number of unit cell, M is what, molecular mass, A cube is what, edge length, and Na is what, your Avogadro numbers have. So here what will happen, here simple funda is there. So what, if you know among these 5, 4 you know, and 5th whatever this quantity you have to calculate, either density, either unit cell, either edge length, either Avogadro number also they will ask to calculate Avogadro number. Okay, they will ask to calculate. So generally what will happen beta, they will ask calculate molecular mass of silver. So definitely your answer what will silver atomic mass, yes, either your answer it will come like this 107.8 grams per mole. Okay, or sometimes 108. So like that also simple numerical asks. Okay, so you can go through your reference book also. Then first you have to concentrate on strictly NCERT. So whenever you're watching this video, you must have NCRT or any reference book. First priority is always for your NCRT. Okay, in that you have to solve first your in-text exercise, in-text question, then you go through exercise, then you go for what, your assertion reason type questions. Okay, then what your one word answer, one short answer, then long answer. Okay, two marks, then 3 marks. Okay, so like that here, if for you know among these five, then fifth you can calculate easily. Okay, so next, whatever imperfections in solids. Okay, so this is also what very much important here, imperfections in solid. Okay, imperfection in solid. So in imperfection in solid, beta here, whatever they give all, yes, a line defects and point defects. So we are continuing with what, point defects. So point defect again categorized into stoichiometric defects and non-stoichiometric defects. Okay, so better way, take one blank page and you have to write your own T diagram here, and like that make, so here suppose here what, stoichiometric defect. So you have to make like this T diagram. Okay, you have to make, so what, how much their types. Okay, then again Frankel defect, Schottky defect. So you have to make, and you have whatever important thing you have to write here. Okay, so strictly you have to make this defect chart, impurity in solid chart, and show it to me. Okay, so this thing is very much important here. You have to make T diagram if possible, but here if only you done T diagram, then and then only here what possible to memorize all these defects effectively. So pay attention and go through like this. Okay, so one of the most important part here I'm going to discussing. Okay, that part. Okay, that part is what, whatever deleted syllabus in solid state. What beta, whatever deleted syllabus in solid state. So in deleted syllabus, so say deleted syllabus. Okay, so say here deleted syllabus what, electrical and magnetic property, electric and what, magnetic properties. Okay, then second what, band theory of metals, band theory of metals. Okay, then conductors, then what beta, semiconductors, then what, insulators, and what, insulators, etc. Okay, so here after insulators, very much important, that is third, N and P type what, semiconductor, N and P type semiconductor. So but they omit this part for CBSE board exam only. In your CET, NEET, whatever competitive exam, it is there. For competitive exam, whatever this part, it is there. So you have to study this also. Okay, only for CBSE exam preparation, you don't do this. But for your competitive exam, you have to do, and all these are what, simpler here. Okay, semiconductor, conductors. Okay, here electrical properties means magnetic property, ferromagnetic, paramagnetic, antiferromagnetism. Okay, so here band theory, valence band, conduction band, how they will, depends on energy gap, they will vary. So this thing is what regarding your what, solid state. Okay, I hope you understood this all, whatever we discuss here, and you have to prepare strictly, you have to prepare accordingly. And if doubt will come, then you can ask during our preparation time, and maximum you do, okay, your devoted study, okay, in that. Okay, so if any doubt will come, you can share on WhatsApp also. Thank you very much.